Hi, sir, I'm Cole. So today I'm solving this problem. So the function in blue is going to our function, our original function. It's a codic function. What I'm going to do here is sketch the directive function of this original function. The first thing to remember is you can interpret the value of the directive at any particular x coordinate as the slopes of the tangent lines on the original. So then we need to find the tangent line that the slope equal to 0 at the original function. So at first I found at here this point the tangent line is equal to 0 because the tangent line is a horizontal line, so the slope should be equal to 0, so mt equal to 0. And we notice that the x coordinate is close -2. Since we are looking at the x coordinate is close to -2 on the directive function, we plot the value of the slope of the tangent line, so we are going to put a point here at close -2 and y equal to 0. Now we can use the same way to find the other points, like here. At this point, we can know that the slope is equal to 0, 2, and the x coordinate is close to 3, and we can, and I'm going to go up and draw a point here. And the tangent line at this point is also equal to 0. The slope is also equal to 0, so we can draw a point here. Now we get 3 points. And then we need to draw the line between them. So at first, let's see these 2 points. Between these 2 points, it's move left to right. Think about the tangent line. When the original graph, the tangent line are going to be positive and positive here. Remember that if tangent line is positive, that means the slope is positive too. So between these 2 points, the slope is positive. So let's draw a point here, maybe. I think, and we just make a point here, and suppose the tangent line here has a slope of maybe, I think, mt equal to 45. Because the tangent line is positive, so the slope is also positive. I just making a number because we don't know the exact data. So at the y coordinate of 45 for that same x coordinate, I will put a point here. And now we know from this point to this point, we know the tangent lines become positive and positive. So from the graph of the directive, the y's value should be positive and positive too. So from the point here to there, the tangent line should become less positive, more negative here, until touch this point equal to 0. So the y's value of directive function should be negative. Now we can use the same way to draw other lines. So from this point to this point, we can see the tangent line is become negative and negative. So we can draw a point here. It's maybe -20, because the tangent line is negative, so the slope should be negative 2. And we draw same here. Now from these 2 points, the tangent line is negative, so we can draw the y's value of derivative should be negative 2. And from the point here to there, it should be less negative and more positive until touch this point equal to 0. So the y's value of derivative function should be positive 2. And now look at the beginning of the original function. We know that the tangent line here is become negative and negative, so the derivative function of y's value should be negative and negative 2. And now look at the end of the original function. We can see that the tangent line is become positive and positive, so the y's value of derivative function should be positive and positive 2. So finally, we get a complete graph of the derivative function. We can see that it's a cubic function. So this is my answer. Thank you for watching.